tab, each window, is its own execution context, its own global execution context. But notice I have these two values and I wrote no code. That's the JavaScript engine doing this for me. So we just learned something. An execution context was created at the global level. There's a global object, meaning that object is available to all the code running inside that window, inside that area, inside that JavaScript file, inside that lexical environment. And there's a special variable that the JavaScript engine created that sits inside the execution context called this. And what we saw was that the global object inside browsers, inside internet browsers like Google Chrome or Firefox or whatever the case, is the window object. And that it did create a variable called this, and at the global level, those two things are equal. This refers to the window object. And you can also just say window and get the global object. Now, just to be really clear, when we say global, in JavaScript, that means not inside a function. Don't think too much deeper than that. That means code or variables that aren't inside a function is global. All right, so we already saw that we have window and this, a global object and this, available to us without a single line of code. Now, what happens when we actually put some code in? All right, let's write our first bit of code. I'll create a variable and call it A, and just give it a value. Hello world. And I'm going to create a function called B, and just leave it empty. Got that? A variable and a function. And now I'll run this, and I'll actually have some code. Now, the execution context is created. This code is not inside a function, although I'm creating a function here. All this code is not inside a function, so it's global. This and window are already available to me, and you'll see something interesting. If I look at window and open it up, remember JavaScript objects are name-value pairs, so here's lots of names and lots of values. The function can be a value. But if I scroll down a ways, there, see that? A and B, my variable and my function. In JavaScript, when you create variables and functions, and you're not inside a function, those variables and functions get attached to the global object. So if I just go like this, A, it's hello world. But I could also go window.a, the global object.a. It's the same thing. See that? So your variables and your functions, when lexically not sitting inside a function, they're just sitting right there on the global object. All right, so when code is executed, your JavaScript code is executed, an execution context is created. At the base level, when you're not inside a function, you have a global object that the JavaScript engine creates for you as part of that execution context. If you're running code inside a browser, that global object is the window object. You get a special variable called this. And in the case of the browser, this at that global level is just the same as the window object. It's equal to the window object. There's also something that is something we haven't talked about yet, and we will shortly. A link to the outer environment. Now, when you're running code inside a function, that means the code that's outside the function. But when you're running at the global level, meaning you're not inside a function, well, there is nothing outside. You're as outside as you can get. There's no outer environment, so that's just null. It's nothing at the global level. But we'll see this come up later, very importantly, when running and executing functions. And finally, the execution context is running your code. If you're creating variables and functions, then that's going to sit on the global object. If you're writing code that is global, again, that's not inside a function. But the important thing here is that there is this wrapper, this execution context, which has these other things that you didn't write. And JavaScript, the JavaScript engine running your code, is doing this for you. All right, so let's move on. So we've seen how JavaScript, the engine, is wrapping our executing code in an execution context. But there's an important aspect, one of those weirder parts of JavaScript, that we need to understand. And to understand it, we just need to dig a bit more into what the JavaScript engine does to create an execution context. So this is the execution context, creation and hoisting. To start with, let's look at a phenomenon that happens in JavaScript that people find surprising and perhaps a bit confusing. I have my simple variable here, a, and my function b. I'm going to actually put a line of code in here just so the function does something. I'm going to use console.log. This writes to that console in the tool window in the DevTools in the browser. If you haven't used this before, we'll be using this an awful lot throughout this course. It's just going to output whatever we put in here out to that DevTools window. So when we see called b, we'll know that we called this function. Now, if I was to call the b function, if I was to invoke it, to execute it, you would normally think I would do this. And I can console.log a after that. So what would you expect to see? Well, I would expect to see called b and then hello world. All right, so let's go ahead and execute this. We'll run it in the browser, hit F12 for my DevTools, and look, exactly what we expected. Now let's do something a little different that in other programming languages you would expect to not work at all. I'll go ahead and go back to brackets, and I'm going to move these calls where I invoke the b function and where I output the value of a to the top of the page. I'll save this. Now what would you expect to have happen? Well, in most programming languages you would expect an error, because programming languages execute their code one line at a time, and since we haven't gotten to the b function, I can't use it yet. That's what you would normally expect. But JavaScript isn't like that. When I go back and refresh this page to rerun the JavaScript, look what happens. It ran the function, and instead of throwing an error, it gave me a value, but not the hello world value that I saved, but this thing called undefined. So even though the function was below where it was executed, it still ran. And in fact, this a variable was available to me, even though it wasn't the proper value. Watch what happens if I just remove it outright. So I'm trying to console.log a, and I don't have it declared as a variable anywhere. Now I actually get an error. A is not defined. But if I put it back so that somewhere on this JavaScript file I have that a variable declared, instead of an error, I get a value, the phrase undefined. This phenomenon is called hoisting. But the way it's explained, I think, can give you the wrong impression. The way, if you look online, that hoisting is explained is that people say, well, that variables and functions in JavaScript are hoisted or moved to the top by the JavaScript engine as if they were moved physically up to the top so that they work, no matter where you put them. But we can tell that that's not quite right because A wasn't set to hello world. So it wasn't like this line was physically moved. It behaves a bit more like this, as if I had a variable declared and then set the value later. But still, that's really not what's happening, because we already said What's executing isn't what you've written. It's being translated by the JavaScript engine. So it's not like the JavaScript engine is physically moving the code that you've typed around and then executed it. So let's undo all this. Here's the code that we wrote. To understand what JavaScript is doing, we just need to dig a little bit deeper into the execution context and how it's created. The reason JavaScript behaves the way it does, that variables and functions are to some degree available even though they're written later in the code, is because the execution context is created in two phases. The first phase is called the creation phase. In that phase, we know we have the global object, which is set up and in memory. We have this, which is set up and in memory. And again, the global object only referring to when we're dealing with the global execution context. We'll see other execution contexts later. But this is always created inside an execution context. There's an outer environment that's created. And in that creation phase, as the parser runs through your code and begins to set up what you've written for translation, it recognizes where you've created variables and where you've created functions. And so it sets up, in this creation phase, the memory space for the variables and functions. And it's that step that is somewhat confusingly called hoisting. It's not actually moving code to the top of the page. All this means is that before your code begins to be executed line by line, the JavaScript engine has already set aside memory space for the variables that you've created in that entire code that you've built and all of the functions that you've created as well. So those functions and those variables exist in memory. So when the code begins to execute line by line, it can access them. However, when it comes to variables, it's a little bit different. You see, the function in its entirety is placed into memory space, meaning that the function, its name, and the code inside the function that's being executed. However, the next phase, the execution phase, which we'll talk about in a moment, where it actually executes your code line by line, that's when these kind of assignments are set, where A equals something. So the JavaScript engine, when it sets up the memory space for A, it doesn't know what its value will ultimately end up being until it starts executing this code. So instead, it puts a placeholder called undefined. That placeholder means, oh, I don't know what this value is yet. That's the same placeholder that we would have if we never set it at all. All variables in JavaScript are initially set to undefined, and functions are sitting in memory in their entirety. That's why it's actually a bad idea to rely on hoisting in any way. You can run into trouble when you realize that that value is actually undefined and not the value you're expecting. So while this technically kind of works, it's better to always do this so that you don't get caught up in that trap. Now, that said, we understand that when we're talking about hoisting, when we're talking about this scenario where I can call the function even though it's declared later, it really has to do with the fact that what I wrote is not what's directly being executed, but the JavaScript engine is then taking my code and making decisions. In this first phase of creating the execution context, the wrapper around my code being executed, it's going to set up the memory space for the functions and the variables that it sees that are going to be used when it starts executing the code. And therefore, we have access to them in a limited way before they actually physically appear on the page inside that lexical environment. Kind of weird, right? But not so much when you understand that it's just phase one. I'm going to set up the memory space. So when the code begins executing, those things are actually already sitting in memory because it looked at your code and already preset things up to be ready for the code to start executing. It's time for another conceptual aside. We've already talked about this a bit, but it's important enough to delve just a little bit into. JavaScript and undefined. We've already seen that there's this first phase of creating an execution context in which there's a global object for the global execution context. There's a special variable called this, which is always created. There's a reference or a link to the outer environment if there is one. And this phenomenon called hoisting, where variables are set up and functions as well. And in the case of variables, they're initially set equal to undefined. But what do we mean by that? Well, let's go back and make our example a bit simpler. I'll get rid of the function and the function call, and we'll just focus on the concept of undefined. So I'll just take my variable a, declare it, and then log it. I'll go ahead and run this in brackets. And we see the phrase undefined. Now remember, we already saw that if I don't declare it at all with the var keyword, it actually throws an error where it says a is not defined. But that's confusing because isn't not defined and undefined the same thing? Well, no, because when we say, and I'm going to put the var a back, in JavaScript, when we see undefined as opposed to that error, this isn't simply the word undefined, but it's actually a special value that JavaScript has within it internally that means that the variable hasn't been set. To prove that, I'll show you something. I'll do if a, I'm going to do triple equals. Now, if you've never seen triple equals before, we'll talk about that at length later in the course. But this is very similar to double equals, is equal to, but it's a bit safer, and we'll see why later. Just for now, we'll just use triple equals because this is good practice, and we'll explain why when the time comes. But for now, just imagine using triple equals anywhere where you would use double equals. All right, so triple equals, and then I'm going to say the word undefined. And then if it's undefined, I'm going to output a phrase. A is undefined. And then I'll put else. If it's not undefined, I'll put console.log a is defined. Notice that undefined isn't wrapped in quotes. This isn't a string. It's a special keyword. It's a value, a special value in JavaScript. And when I go back and run this, notice that a is undefined. So when this if statement checked if a was equal to this special keyword, this special value undefined, it said yes, it is. If I was to set a up here equal to a value, then by the time we get down here, a is set, and so a is defined. This was false. It was not equal to undefined. But if I don't set the value, again, this will be true because the initial phase of creating the execution context sets all variables equal to undefined. And if you don't do anything else, that's what that value will be. Notice again, this is different than if I simply never declare the variable var a and attempt to console.log a. When I refresh this, it gives me an uncaught reference error, a is not defined. That's because that initial execution context creation, that creation phase, when it went through, it didn't find a var a, so it never set up the memory space. So when it went to execute this code, it said, hey, I don't have A in memory at all. So it gave you an uncaught reference. A is not defined. I don't have it in memory. That's what the browser is saying. That's what the JavaScript engine inside the browser is saying. However, when I declare var A is placed into memory during the creation phase. So the execution context saw var A and set up A in memory. And so even though I haven't set it to a value, the JavaScript engine, which is doing more than what I'm just writing in my code, already set it to this special value called undefined. So undefined is not like empty or doesn't exist. It doesn't literally not exist. It's actually a value. It's actually taking up memory space. It's a special keyword, a special value that means this is the value that was initially set by JavaScript. And that leads to a little bit of a warning. Never do this. Never set yourself a variable equal to undefined, because actually you can. For example, I could set this initially to hello world, and then console.log it, and later for some reason set it to undefined, and we'll see that it is. Watch. Hello world, and then later it's undefined. That's perfectly valid JavaScript, but it's a little dangerous. It's better to let undefined, that special keyword, mean I, the programmer, never set the value. That will really help you when debugging code. If you make a habit of setting values equal to undefined, then it's really hard to tell if something is undefined because you set it, or because the JavaScript engine set it and you never set it to anything else. It's always better to let undefined mean I've never set this value. That's really useful, and it will help you in your debugging. So undefined, this is a special value that is also a special keyword in JavaScript, and it's the value that variables receive during the creation phase. The first phase of creating an execution context sets up the memory of the variable, and in that memory space puts the value called undefined. I would have called it something else personally, like not set, but that's what JavaScript calls it, undefined. And if you don't, in your code, set it to anything else, that's what it will be. Or if you set it something else later and use it beforehand, that's what it will be. All right, so that's JavaScript and undefined. All right, so remember we said there were two phases when it came to the execution context within the JavaScript engine. The first phase was the creation phase, when it set up the variables and functions in memory. And then the second phase is the execution phase. And this phase is pretty simple to understand. In the execution phase, we already have all those things set up that we had before, and now it runs your code, the code you've written, line by line, interpreting it, converting it, compiling it, executing it on the computer into something the computer can understand. And it runs your code line by line. So if I go back to our example that we used for hoisting, and I console.log A here, and I'll just go ahead and move the function to the top so we're using good practice so we don't have confusion. I have a function and I call it. I'm logging A. I'm setting A to equal to a value and declaring it, and I'm logging A again. So what do you think we're going to see? B will be called, then A will be logged, then A will be logged again. We're going to see 3 lines because console.log is also called. So what are the 3 lines? What's the line here? What are we going to see here? And what are we going to see here? All right, let's go ahead and run this, refresh. Did you get it right? It called the function. The first time it called a, it got undefined. And the second time it got hello world. Why? Because now we're in the execution phase. So in the creation phase, we set up this function, and var a was set up and set equal to undefined. And now it begins to execute code. So line 5 is executed and it runs that function. Line 7 is executed and it outputs the value of a to the console. And since a was set to undefined in the creation phase, that's what we see. Then it executes line 9 and sets the value in memory of a to the string hello world, exclamation mark. And then in line 11, it once again outputs the value of a in memory to the console, which is now hello world. So it just executed these things line by line. And we understand between these two phases, the creation phase and the execution phase, now why we see what we see and why JavaScript behaves the way it does. It's time for another conceptual aside when it comes to JavaScript. This one is single-threaded synchronous execution. So we have two rather large-looking terms, so guess what? Big word alert. First of all, single-threaded. It sounds pretty complicated, but it's easy to understand. That means that one command is being executed at a time. So any program is full of many commands within the code. Single-threaded execution means you're only doing one at a time. Now, when we're dealing with browsers, understand that JavaScript isn't the only thing happening in the browser. So when we say JavaScript is single-threaded, it may not be under the hood of the browser. But from our perspective as programmers, JavaScript behaves in a single-threaded manner. All right, the next one. And once again, big word alert. Synchronous. This is very similar to single-threaded. Synchronous meaning, in the purposes of programming, one at a time. Not two at a time or three at a time, but one line of code being executed for synchronous execution at a time, and for our purposes, in order. So the code is executed one line at a time in the order that it appears. And that's it. Single-threaded synchronous execution, meaning that in JavaScript, only one thing is happening at a time. Now, I know what you're probably thinking, but hey, I've heard of asynchronous requests in JavaScript, especially on the web. AJAX, the A stands for asynchronous. What are you talking about? Well, we'll see that in just a little bit. But for now, just trust me. JavaScript is single-threaded synchronous execution in its behavior. All this time, we've been talking about the global execution context and how it's created and executed. But we also mentioned that functions are special in regards to this. Here we'll talk about function invocation and the execution stack. And we're going to introduce this concept that will be fundamental to understanding some very important and advanced concepts in JavaScript. Before we do that, though, we've rather casually used a word here, a word that sounds a lot more complex than it really is. Big word alert. Invocation. That just means running a function or calling a function. So when we say we invoke the function or function invocation, we just mean, hey, run the function. In JavaScript, we do that by using parentheses. You put the name of the function and then put parentheses. When you did that, you invoked the function. You told the JavaScript engine to run it. So now let's talk about what happens when you invoke a function in JavaScript. To do that, let's look at a simple example. So I have a function b that I've created. It does nothing. A function a that calls or invokes function b, and then I'm invoking function a. This is a very simple example, but it helps us to understand what's happening under the hood. Now here comes this fundamental, very important concept. Let's step through what we know is going to happen first if I put this code in a JavaScript file and ran it. First of all, what's going to be created? That's right, a global execution context. The parser will parse the code, and then the compiler, the program that's going to interpret your code, will start up and say, well, I need to create a global execution context. It'll create the variable this. It'll create a global object. If you're in the browser, it will create a window object. And then it will attach these functions to it. It will set up the memory space for them in the creation phase of the execution context, that first phase. So B and A will be in memory. And then the code will be executed line by line. Now, it won't execute anything in those functions because they haven't been invoked. But when it hits A at the bottom, and it says, I'm supposed to invoke or call or run that function A, here's the thing that actually happens. A new execution context is created and placed on what's called the execution stack. And the stack is just what it sounds like. One on top of the other on top of the other. And whichever one is on top is the one that's currently running. So anytime you execute or invoke a function in JavaScript, a new execution context is created and put on the execution stack. So the execution context is created, just like the global one. It will have its own space for variables and functions. It will go through that create phase, and then it will execute line by line the code within the function. However, if I have another function invocation, it's going to stop at that line of code and create another execution context and run that code. Now, in the case of B, there is no code to run, but this is how function invocation happens in JavaScript. Every function creates a new execution context, which runs through the create phase and then executes the code line by line within the function. When B finishes, because it's at the top of the stack, it will get popped off the stack, then A, then back down to global. Notice that this doesn't matter. The order lexically doesn't matter, nor does the rest of the code that happens to be surrounding those function calls. For example, let's suppose we put A above B and we had some other code surrounding these function calls. That doesn't matter, because even though lexically A is above B, remember what's happening. Both of those functions are already in memory during the create phase of the initial global execution context. Those var c, var d that you see down below, each of those function calls, let's talk about what's going to happen. First of all, A at the bottom will invoke function A. So that will be the next put on the execution stack, the execution context for the function A. Then that becomes the currently running code, which means that very last line at the bottom, var d, below the A, that's not going to be run yet because JavaScript is synchronous, one line at a time. And what's running is the current code within the current execution context, which is the one at the top of the stack. So when A is at the top of the stack, it will start to run line by line. It hits that line where it invokes B. B creates a new execution context, so that becomes the top of the stack. And so it is running line by line. And it runs its single line of code there, and only when it finishes will we go back to finishing A. Why? Because when the function finishes, the execution context is what's called popped off of the stack. So now what's the current execution context again? A. So it runs the next line of code that hadn't yet been run inside that execution context, meaning that var C line. And then when A is finished, it's popped off the stack, and the next line of code that hasn't yet been run in the global execution context is run, which is that very last var D. See how that works? Every time a function is called, a new execution context is created for that function. The this variable is created for that function. The variables within it are set up during the creation phase. And the code is executed line by line, but every time a function is invoked, even if it's invoking itself, a new execution context is created, put on top of the stack, and then when the function finishes, it's popped off. And whatever's at the top is what's currently running, line by line, synchronously. This concept is very important to have in your mind as your mental model for what's happening as you're invoking functions, because it has to do with the rest of what we're going to discuss. So let's move on talking more about functions, context, and another addition, variable environments. Here's another phrase that's used when talking about JavaScript under the hood. It's a lot more complicated sounding than it really is. Variable environments? Well, big word alert. The variable environment is just talking about where the variables live that you've created and how they relate to each other in memory. So when you think about the variable environment, just think about where is the variable. Let's move on from there. Let's look at a piece of sample code. Again, I have two functions, a function B and a function A. Inside function B, I declare a variable called myVar and don't set it equal to a value. In function A, I set a variable called myVar also and set that equal to 2. And then outside the functions, I also declare a variable called myVar again and set that equal to 1. Then A is called, and inside A, B is called. So what's going to happen? What is the value of myVar at any point in time? To answer that, we need to think again about execution context. What's happening as these functions are invoked? So, at first, what happens? The global execution context is created, and so that bottom myVar is put into memory space. In the case of the global execution context, its variable environment is the global object, or a window in a browser. So then the code is executed, and that memory space will get a value of 1 when it hits that myVar equals 1 line. And then it hits the invocation of A. And what happens? A new execution context is created for A. And when it's created, that myVar will be put into that execution context variable environment. See, every execution context has its own variable environment. And its value will then be 2 during the execution phase when that line myVar equals 2 is run. Then it invokes B, and a new execution context with its own variable environment, its own memory space for its variables, is created. And since it's not set equal to a value, myVar will be put into memory with a value of, as we've learned before, undefined. This has to do with something called scope. Just means where are we able to see the variable? Each variable that we are looking at is defined within its own execution context because it's within a function. And every time you call a function, you get your own execution context. So even though the myvar is declared 3 times, they're distinct, they're unique, and they don't touch each other. All right, let's prove that. I've put my code into a JavaScript file, and I've added some console.log so we can see the values. So we set myvar equal to 1, log it, then call function A, which will create a new execution context on the execution stack on top of the global execution context. So this will be the running code. It will create myvar in its own variable environment, log it, and then we start another execution context by invoking a function, and it will put its own variable called myvar into its variable environment, and we'll log that. So what should you expect to see? Well, we're going to expect that we'd see this console.log happen first. It runs A, so we'd see this one second, and then it runs B, so we'd see this one third. So I should see 1, 2, and what will be the value if I haven't set a value? What value does the execution context creation phase set all variables to? That's right, the special value, undefined. So I should see 1, 2, undefined. And so I'm going to go ahead and run this and open up the developer tools, go to the console and look. 1, 2, undefined. Exactly as we expected. So each of these myvars is sitting in its own execution context. Calling this function didn't affect this myvar. Watch, I'll console.log myvar after calling A. Should that have an impact? The answer is no, because once we finish A, the currently running code is the global execution context, where myvar is 1. So I should see another 1 when I console.log here. Let's say that again. This code is running inside the global execution context. These variables are attached to the variable environment of the global execution context. So when I log this, I see a 1. This calls, and this runs, and that's its own execution context with its own variable environment. The same with B. So when I leave B, A finishes, and when A finishes, I'm back to the global execution context because the B and A execution contexts have been popped off the stack. They're gone. The currently running context is the global execution context. And what was myvar in that context? 1. So I'll save this, run it. What should I see? That's right. 1, 2, undefined, 1. See that? 1, because that's inside the global execution context. 2, because that's inside A's execution context. Undefined, because that's inside B's execution context. And then 1 again, because we're back to running inside the global execution context. Got that? Does it make sense? Try this code out for yourself. Mess around with it a bit. See if you understand it. Remember, this is important. And as we move on, if you've got this concept down, it will reveal another concept that's interesting, fundamental, and often causes confusion. But you are going to understand it. Let's move on. This next lecture is on a concept that confuses a lot of people. But now that you're armed with your understanding of the execution stack, execution contexts, and variable environments, the scope chain won't be that difficult for you to understand. Let's take a look at another piece of sample code. Very similar, we have function B, function A, and the myvars again, except in function B, we're not declaring myvar. We're just going to console.log it. So what do you think is going to happen when we get to that line in function B and we console.log myvar? Remember, when B is invoked or executed or run, it creates a new execution context, puts it on the stack, and puts into its variable environment any variables that are declared. But myvar is not declared. So what do you think is going to happen? Let's put the code into our JavaScript file. Again, I'm console.logging myvar inside the B function. And here myvar is 1, here myvar is 2. I'm invoking B, console.log, and at the end I'm invoking A here, so that's where this will all start. So what do you think I'll see in the log? Let's run this. And when I look in the developer tools, in the console, I get a 1. A 1. The value that was sitting here at the global level. Is that what you expected? Some of you might have expected it to be undefined because we didn't define myvar, we didn't declare it inside this function, inside its variable environment. And maybe some of you thought it might be 2 because we called B from function A, and maybe somehow it would know what its value was there. But instead, it's 1, the value at the global level. Let's see why. So remember this. Function B, console.log myvar, was a 1, or what was sitting on the global execution context. Not undefined, not 2. Why? Well, remember, we have our execution stack. At the global level, it was 1. When A is run, we also varred myvar, and that was a value of 2. And then when B was executed, we just console.logged, and we didn't declare anything. And that was just empty. There is no myvar in that execution context variable environment. But when we request a variable, when we do something with a variable, JavaScript does more than just look in the variable environment of the currently executing context. Remember that each execution context has some special things that get created for you, like the variable this. Remember, we also mentioned one other thing that we haven't used yet, the reference to the outer environment. Every execution context has a reference to its outer environment. Now, what is its outer environment? Well, in the case of function B, its outer environment is the global execution context. And that's also the case in function A. Even though A is directly below B in the execution stack as far as what code is going to run, that little outer environment reference that each execution context gets doesn't necessarily have to be the execution context directly below it. Instead, it's something that we've already talked about. What kind of outer environment are we referring to? Remember that big word that we used almost at the beginning of this course? The lexical environment. Wait a minute. Back up. Lexical environment? Didn't that mean that where something is written physically in your code is important? That it determines certain things as far as how the JavaScript engine will decide and interpret where things live and where things will sit in memory and how they'll connect to each other? That's right. So where does function B sit lexically? It lexically sits on top of the global environment. In other words, it's not inside function A. It's sitting right there at the same level as that last line where myvar equals 1. Now, don't get lost about this. We're not changing our minds in that the execution contexts don't matter, don't regard where something is sitting physically in the code. It doesn't. The B could be above the A could be above the B. It doesn't matter. What's going to happen is the order of execution will determine how those are invoked, how those execution contexts are created. However, JavaScript does something special. It cares about the lexical environment when it comes to the outer reference that every execution context gets. And when you ask for a variable while running a line of code inside any particular execution context, if it can't find that variable, it will look at the outer reference and go look for variables there, somewhere down below it in the execution stack. And that outer reference, where that points, is going to depend on where the function sits lexically. So my B function sits lexically, not inside A, but at the global level, right smack dab at the outmost point of the code. And so its outer environment, its outer lexical environment, is global. And so is A's. In JavaScript, when I asked for my var inside that B execution context, it couldn't find it. And so it went down and found it in the global execution context. So again, these execution contexts are created, and it doesn't matter where the code is physically written, where these functions are physically written in regards to when these execution contexts are created. That has to do with when you invoke them. But when you invoke them, when you invoke a function, the JavaScript engine creates an outer reference for that execution context, and it looks at where the code was physically sitting. The syntax parser already knows, because it went through line by line your code, and it knows where that function was written, and it then creates the appropriate outer reference based on where your function was physically written in the JavaScript file. Now, this entire act of searching, this chain of references to outer environments, because this execution context stack could get really tall, and maybe my var is a ways down the stack. It has to search one and then look for another outer environment and search again until it gets all the way to the bottom where the global is, where there is no outer environment, to find my var. So if I had several more functions calling each other, it would keep on moving down until it hit global, if those functions were defined inside each other, down those outer environment references until it finds it or doesn't. That whole chain is called the scope chain. Remember, scope means where can I access a variable? And the chain is those links of outer environment references, lexical, that is where it was physically written in your code. So when we said inside function B, console.log myvar, it looked for myvar, couldn't find it, and went down the scope chain. Now, it's going to go down the execution stack, but it jumps because it's not necessarily right below it. The outer environment, in this case, lexically, was global. All right, let's show how we can change this by changing the lexical environment of the function. All right, so let's take a look at function B again. Where is it lexically? Well, it's lexically sitting in the global environment. Remember that this is where it sits. It's actually attached to the global object. It's declared lexically, physically, at the same spot that myvar is. It's not inside a function, it's just there on the JavaScript file. So, the JavaScript engine, when it generates the execution context, when B is called, it creates that execution context and creates an outer environment along with the this variable and other things. It creates an outer environment reference to the lexical environment. That is to say, hey, The JavaScript engine saw that the function is sitting physically here, or it could also be sitting physically here, doesn't matter. It's sitting physically, though, not inside any other functions, so its outer reference is the global execution context variable environment. So when it looks for my var, it can't find it in here, so it goes down the scope chain, skips over that A execution context because it's not lexically in there, and finds it here. So when I run this code, I get a 1. But if I change the lexical environment and put function B inside function A few things happen. I've changed the lexical environment of B, meaning that I've changed where it physically sits in the code so that it's inside a function. And so its environment is different. Immediately, that means I can no longer just call B out here at the global level, because what will happen is the global execution environment will look for the function B, but that was never added to its variable environment because it's inside A. So the JavaScript engine, when it created the global execution context, it found function A and added it, but it didn't go look inside function A or anything like that. It just went to the end of function A and kept going. So there is no B in the global execution context. So I'm going to get an uncaught reference. B is not defined. See that? Because that first creation phase didn't find function B in the global execution context was created, only function A, because that's where it's sitting lexically. Function A is visible lexically, but not B. However, when I call A, did you notice what the value was? I called A. A's execution environment is created, its execution context, and when I call B, what's my var? 2. Do you see what just happened? All right, so what just happened? Well, the same execution contexts were created. A global, and then A was called, and then B was called. However, because B was sitting physically inside the A function, the JavaScript engine said, well, its outer reference will then be A, because that's where it's physically sitting. And A's would then still be the global. And so when we asked for myvar this time, when it went down the scope chain because it couldn't find it in B, instead of going to global, it went to A. Found myvar, it said, hey, you asked for myvar, and when I went to the outer lexical environment, I found myvar, and so it's 2. Make sense? The outer lexical environment of B is A this time because B is physically sitting in the physical code that we typed. It was physically sitting inside function A. So where something sits physically, thinking lexically, is a really easy way to figure out how something will be found along the scope chain. In other words, if I don't declare a variable inside a function, where will I go find it? So function B is sitting inside A. So if I don't declare it inside B, it will go look for it first inside A. If it can't find it inside A, A's outer reference is to global, and so it'll look for it there. So notice I just got rid of that. It's back to 1. See, it went up or down, depending on how you want to think about it, the chain, the scope chain. So I look for myvar in the B execution context. Can't find it. The outer reference is A. Can't find it. The outer reference of A is global. Hey, there it is. See how that works? Now, another way to think about this, if you don't want to think lexically, is who created me? The outer reference is to the execution context in which the function was created. So in this case, function B isn't created until A's execution context is created, right? Because the global is just going to add my var and A. Then when A is run, it's going to go through its create phase and say, I need to create B. And since B was created during the creation phase of A's execution context, that's its outer environment. If I moved B back out, then now when is B created? B is created when the global execution context is created. And so that's its outer reference. It's a different way of thinking about it. It still works. But the fastest way to think about it, in my opinion, is thinking about it lexically. That way you can just look at your code and know, oh, if I have code that looks like this, this is going to be a 2 because of where it sits physically, lexically. Make sense? All right, so again, if I just remove all of this, it will go all the way up the scope chain, and I still get a 1. All right, so we've learned that where a function sits determines its outer environment reference. But as it's being executed, those execution contexts are stacking up, and it's running synchronously. We've learned quite a bit, and we're understanding the scope chain. This concept can be confusing for people. It can be a little weird. But if you understand what's happening under the hood of JavaScript, you'll be able to determine what's really happening to your code. And when you have a problem, when a variable is an unexpected value, you'll be able to debug it and say, I know why it is what it is, because I know how this really works. All right, let's move on. So we've talked about execution contexts, execution environments, variable environments, lexical environments, and all of these things ultimately